Five. All right, here we go. Let me get this camera ready. Get it focused in on our experiments. And let's do it. What are we going to do today? Let's just start out nice and easy. I'm going to add a little bit of universal indicator, also known as rainbow indicator, to our flask. Here we go. There goes our first squirt. That yellow color I see, that's telling me something there. That's actually telling me that the pH of my tap water, actually I'm using distilled water, sorry about that. I'm using distilled water I bought at the store. That's purified water. Its pH is a little bit acidic, which might sound a little odd because the water's fairly pure. See here, let me turn a little light on so you can see my pH scale for you. There we go. Right, that's a nice yellow color. It's just below neutral. So pH neutral is pH 7. How you doing there, Nick's Trail? Good to see you. We got a pH 6. That's slightly acidic solution. It's because there's some carbon dioxide that's dissolved in the water. Yeah, any water that's exposed to the air will have a little bit of carbon dioxide dissolved in it, and that makes it acidic. Let's add a little bit of let's add some hydrochloric acid. Same acid that's found in your stomach. And let's watch what happens. Here we go. A couple drops. Like 2 drops. Sure enough, we get a nice red color. Beautiful red color. pH is dropped, man. We're down to like pH 3. Let me get a little better sheet here. pH 3, right? Nice and acidic. Now we're going to start adding drops of sodium hydroxide base. The chemical reaction, it'll react with the acid that's in there, and it's going to form salt water, so it should neutralize it. Let's add a drop of base here. Sodium hydroxide, in goes 1. First drop. That's gorgeous. That violet color you see is highly, highly basic, highly alkaline. Looks like we changed it pretty quickly, all the way up to like pH 10. That happened quite fast. Yeah. Our pH is very high now. pH 10. pH 10. All right, I'll start adding acid, and we'll head back in the other direction. So there's sodium hydroxide base in there. I'm going to start adding hydrochloric acid, 1 drop at a time. There's our first drop. Nice. There's our second drop. We are back to acidic. Add a little bit of base. Here we go. Sodium hydroxide. Let's see what happens there. 1 little drop of base. Boom. Oh, that really makes it a basic alkaline fairly quickly. I think my base is a little more concentrated than my acid. Let's start adding I'm going to add a drop of acid there. 1 drop there. Look at that little flash of the rainbow, huh? It's beautiful. Look at that. Another drop of acid. Gorgeous. Let me turn the speed up just a bit, the stir speed. There we go. Add a little more universal indicator as well. Just give it a little bit more color. Just a bit more. Give it a little squirt there. Oh, look at that nice cherry red. Gorgeous color. So that's very acidic. We got a lot of hydrochloric acid in there. It's the same acid that's found in your stomach. We're going to give this a shot of base, baby. We're going to try to neutralize the hydrochloric acid that I just added with a drop of sodium hydroxide. In it goes. 1 single drop. Boom. Nice. Boy, that changed it way to alkaline fairly quickly. Let me try to just pull that back a bit. I'm going to just start adding a few drops of hydrochloric acid. Look at that, man. It's like the day breaking through the tornado that's just swirling through the night. Isn't that gorgeous? Man, that's pretty. Another drop there. Let's add our base. Sodium hydroxide base. How you doing there, Tennessee? Good to see you. Welcome aboard. Get a little drop of base in there. Come on, baby. See if we get a little rainbow action going. Yeah, it does. I agree, weed smoke. Oh, look at that. I've almost perfectly neutralized it. Actually, that's about pH 8 we're looking at. Let me show you the pH scale, the colors at the different colors you might see, the different ends of the pH spectrum. This is my acid base indicator that I'm using, universal indicator. You can see that nice aqua color. That's indicating a pH 8, right? So we're just slightly alkaline. I'm going to add another drop of base here. We should see a blue color. Sorry to hear that, Tennessee. I hope you're coming along. Hope you're coming along well. Now we got a pH 10 with that violet color. I'm going to start adding some acid. Hydrochloric acid, same acids found in your stomach. We're going to pull it down in the other direction. How folks doing out there today? Let me know in the chat. Let's add 1 drop of hydrochloric acid. We're going to add another drop there. That's pretty. Another drop. That one should give us a bunch of colors there. Hey, thanks there, Mark. Appreciate it. So Tennessee's potassium was low. Oh, that's scary. Oh, I'm so sorry to hear that, Tennessee. I hope you're, man, I hope things are coming along well for you. That's scary stuff, man. I hope, you know, I hope you're healing up. Your potassium was at 2.8. You know, I don't understand that, so you might have to help me out and the other viewers. I don't understand like what normal ranges are. How you doing there, Gray? Welcome aboard. We right now have a red tornado, don't we? That's red in there because we have hydrochloric acid in solution with some universal indicator. And our universal indicator is going to show us that if indeed we are red, we got a pH of 3. I see. That's a bit low, man. Sorry about that, Tennessee. We're going to start adding some base. We're going to watch what happens to the colors as I add sodium hydroxide. That's going to neutralize the hydrochloric acid we have in there. I'm just going to do 1 little drop of the base. In it goes. Oh, I saw a quick rainbow flash. We are immediately at pH 10, man. We went from pH 3. Man, we went from pH 3 to pH 10 like crazy. Quickly. Here, let's try this. Let's just do this. I'm going to add a drop. We're going to add some acid to lower the pH. In goes the first drop. In goes the second drop. So the way this indicator works is on the blue end of the spectrum, the blue end of the color spectrum. That's alkaline or basic. I'm adding acid to a base right now. And on the red, orange, and yellow end, that's acidic. If it's green, if everything ends up green, that means we're perfectly neutral. You can see we're kind of acidic right now. That'd be nice, man. That'd be nice to get some Tennessee well water. I'm continuing to add acid here. Now what I'm going to do is I'm going to turn the stir bar off while we do some experiments on the other side. But while we're doing this, let's just add, I'm going to add like 2 drops of base here. Let's just add 2 drops and see what happens with the stir. There's the first one. You can see the base just ripping through there. So the base is going to color the universal indicator a violet color. Thank you there, Bald. I appreciate that. Appreciate that a lot. I'm going to just zoom back a little bit so we can kind of keep. How does a tornado get bigger, Gray? It would be if I turn the stir speed on quicker. Here, we'll just do another one. We'll do a different on this other side. I'll do some different water. This has universal indicator in it. Excuse me. This has distilled water in it, and the distilled water that changes color rapidly because there's nothing to buffer the water. So let me see if I can't get some water that's going to be a bit more buffered. We should see some color changes that persist a little better. Let me just see here. Some water I might get. Let's use this. This should work. I'm going to use some essential water, okay? Essential water. We're going to pour it in here. Pour it in this second one that we'll keep running. Kind of cool over here. We have a flask that has both pH 3, that's the red color, and pH 10, that's the violet color, in at the same time. That's a difference in 7. But because the pH scale goes by powers of 10, the difference of acidity that you actually see in here is 10 times 10, 7 times. And 10 times 10, 7 times, that's 10 million. So the difference in acidity between the bottom of the flask where it's red, that's high acid, and the top of the flask where it's violet, that's alkaline, that's 10 million times more acidic down here than it is up here. And as you'll notice, as the acid and the base react, you might see some wisps of other colors, because what will happen is the acid and the base, this should be violet down here, the acid and the base react with each other and they neutralize each other. And as they neutralize each other, you're going to see some of these intermediate pH values grow in. Like over here, I can see some wisps of yellow and green. Okay, now over here, I have a flask that has a, what is that? Is that a scratch? It is a scratch. We'll just turn that so you can't see it. There we go. Make it look a little prettier. There we go. Now over here, I'm going to add some universal indicator to essential water, which it's alkaline. They do sell it as alkaline. It is pretty there, Gray. It is a cool gradient there, Tim Smith. Thank you, the wasabi noodle. Wasabi noodle, like the name. So you see, yeah, that is definitely alkaline water. As I'm adding it, that aqua blue color is developing in. Actually, it's looking kind of bluish violet, isn't it? The universal indicator itself is kind of a green. And then when I add it to the essential water, that's been diluted a little bit. It looks like it's turning a blue color. Okay, now this one has some dissolved minerals in it, which should buffer the system a little bit. So it'll just take a little bit more to change the pH. I'm going to add a drop of acid here, just one drop. That is a gorgeous, yeah, look at that. You see how the buffered material, the colors persist a little longer. Gray, I apologize. I don't completely understand your question. If you could be a bit more precise, that would help me out. I'm sorry. I don't want to go answering something when I don't really understand the question. I'm turning up the stir speed a little bit. Just check out the pattern over there, man. Look at that gorgeousness, huh? Just kind of beautiful. Okay. Let's get back to our experiment over here on the right. It's acidic. I'm going to start adding some base. I think I want to add just a bit more universal indicator so we get a bit more color. Make it look prettier here. All right, and it goes. Yeah, get that cherry red going, man. Get that cherry red going. All right, now what I'm going to do is I'm going to add a little bit of base, and we're going to see what happens when I add the base. Here we go. Man, that color over here is developing really cool. Here we go. Let's add a drop of base. Boom. So we've got oh yeah, that was beautiful. Really pretty. Add another drop. It's working well. Oh man, that was cool. Wasn't that cool? It looked like a flashlight or a stoplight there for a second. The red fluid from the ancient dark sarcophagus. Love it there, Dag. Hello there, young Carlo. Sorry if I mispronounce y'all's names. Certainly correct me. All right, let's add some acid to this flask over here. There's a drop. There's another drop. There's another drop. There's another drop. Let's see what happens here. Look at that. It's like the daylight breaking through the night from the bottom up. Just look at those patterns, though. Very gorgeous. Very gorgeous. Looks like we ended up at about pH 3 over here on the right, which is quite acidic. Yeah, maybe 4 or 5. So these are the different colors you're going to see. Red through, this should be violet. I spilled a little water here, which erased the dye. But, you know, these are your acidic pHs. These are your basic or alkaline pHs. And right there at pH 7, that's if I get the acid and base completely balanced, completely neutralized. We'll add a little drop of acid over here. Get this down to like pH 3 where it's a nice cherry red. Man, look at that spot right there. Look at that little red spot. That's a really acidic spot that's near the bottom. Isn't that interesting? I'm sorry, I'm going to zoom in on this just for a bit. That looks really beautiful. What the heck, man? Yeah, that's cool. Very cool. So yeah, I've got a static flask on the left. So Aiden's got a question. While we're watching all this develop, I'm going to start pouring. I don't say pour. I'm going to start dropping base on the right. Aiden's got a question. What if you just pour 98% concentrated sulfuric acid all over yourself? Aiden, it wouldn't end well, man. So sulfuric acid is a very, very good dehydrating agent. It's like so good. So like carbohydrates, those are chemical species in which the ratio of it's carbon containing. So carbohydrates, carbo, have hydrogen. The hydrate portion of carbohydrate means that there's also hydrogen and oxygen, as there is in water, in a carbohydrate. But the ratio of hydrogen to oxygen in a carbohydrate is the same as the ratio of hydrogen to oxygen in water, which is H2O. So carbohydrate has carbon, hydrogen, and oxygen in it. And sulfuric acid is a very good dehydrating agent. It will pull water out of, it'll pull it out of a carbohydrate. And so if you like pour sulfuric acid on a sugar, what'll happen is the water will get removed from the carbohydrate chemically, and you end up with this big, black, massive snake that's just the carbon that grows out of the container. And the water just kind of, it gets so hot, it emits gaseous water vapor. It's a really interesting, they call it the carbon snake. So I know you're not, humans are not made of carbohydrates or made of protein, but we do have carbohydrates in us. But long story short, that same type of thing's going to happen to you if you pour it on you. And so, messing with concentrated sulfuric acid is not going to end well for you. All right, so gray, it is, look at that, John Doe. That is a really cool pattern we have over here that I've not seen before. Definitely like painting in liquid form. It is, Baldric, like watching an aurora. I agree with you. Small acid colony trying to get to the bottom. I love it, Dag. Gray asks, how come the tornado in the right glass touched down when you add the thing to it that turned from clear to blue? I think I understand the question. And Jamaris, the base I'm using is sodium hydroxide, 20%. What if I put all of it in there? Anthony, I have a lot of different things, so I don't completely understand what you mean by all of it. Hello there, Apex, and thank you there, Mike. Not going to say your last name. So, back to the question. How come the tornado in the right glass touched down when you add the thing to it? Okay, so in this flask, we have a vortex, right? We're going to focus in on this glass over here just for a bit. I have a vortex, right? And we can think of it like the eye of a hurricane. And just like the eye of a hurricane is very low pressure, the very center of this vortex is also very low pressure. Now, material moves from higher pressure region to lower pressure region. So that means that the material in the flask on the outside of the vortex is going to find its way into the middle, moving from high to low pressure. If I put something in the center of the vortex, like this sodium hydroxide, it's going to change the color from red to any of these colors as the acid gets neutralized, okay? But that basic material, it's in the low pressure region, it's going to stay there. So that's why it just stays in that middle region and moves down and touches the bottom. Now, once it hits the bottom, it gets pushed out along the sides, and, that's when things get dispersed all the way through. But initially, here I go, I'll add another drop. Initially, it stays right there in the middle. Come on, man, that was cool, huh? Wasn't that cool? Oh. Let's see what else we got going on. Yes, John Doe, the sugar and sulfuric acid. Apex, what I'm doing right now is adding acid or base to flasks that contain universal indicator. Thank you there, Ivan. I appreciate that. Thank you there, Eric. I appreciate that. All right, I think I caught up with the comments. What I'm going to do now is I'm going to mix this side up, okay? We're going to mix it up. We're going to reset this one so you can kind of watch. Hey, look at that. Both are green. Both are perfectly neutral. That's kind of nice. So we're starting out, well, maybe pH 8. Maybe they're like pH 8, somewhere in here, just slightly basic. I'm going to go ahead and start adding acid to this side. We're going to get a nice low pH. So I'm going to add some acid here. We're going to see that's going to produce a nice red color. We'll do the same over here. Get the same red color. Takes a little bit more on the right because this is slightly buffered. That means it takes more acid or base to change the pH. There we go. This side, I'm going to turn the stir speed off. Thank you there, Dag. I ain't lying. Actually, I am, Patricia. I'm adding sodium hydroxide. You know the drill. I love it. Can you blow through it through a straw? Yeah, I'll do that, Mike. I will do that. So Mike wants to see that experiment. So we'll do that. Let me go ahead and add some sodium hydroxide over here to the flask. We'll do like, I think 1 drop might work. Let's just get 1 drop in there and we'll just see what happens, okay? So that's all I did. That's all I did to this flask on the left last time as well. So Mike wants me to show that blowing through a straw into basic water, alkaline water, acidifies it. So give me a second here. Oh, we're going to use some of this. And let me get a good flask for this. Thanks for bearing with me, everybody. Here's this flask. And let me get a straw. Do I have straws? Oh no, I better have straws. Yes, I do. I got it. Perfect. Awesome. Okay. So we're going to remove this flask for a bit. We're going to put this one here, okay? So what I have now is some... Hold on, let me see what the comments here say. Yes, that was a magnet spinning at the bottom. Wasabi noodle. Can you substitute sodium hydroxide for sodium peroxide? No, Dag. Those are different substances. Could you also, although I don't know what sodium peroxide makes when it hits water. That might just make sodium hydroxide. But sodium peroxide, that's some pretty nasty stuff. You got to be careful with that. Could you also make sulfuric acid with Epsom salt using electrolysis? Man, Aiden, I'd have to think about that for a bit. Sorry, that's going to take some thinking on my part that I'm not going to be able to answer right off the cuff. I apologize. Okay, so now what we're going to do is I'm going to take some of this body armor. You'll see it says alkaline water. It's basic. So we're going to expect the pH of this stuff, right? The pH of this stuff should be somewhere in this region. It shouldn't be green. It should be like this aqua, blue, or violet color. Let's see what let's see what it says. I don't see it tells me the pH, but here, we'll go ahead and open this up. Pour it in here. Yeah. It's probably enough, just like that. All right, I'm going to add a little universal indicator, and I'll expect the manufacturers are not lying to us. All right, in goes the universal indicator. A little squirt. Sure enough, that is very, very basic. It's like a violet or a blue color. More blue, I'd say. And I'm going to blow through a straw into it. Dag, what's healthy? Any of those waters are fine. Any of those waters, it depends what you're looking for in terms of health. But if you just want like water that's just hydrating, any water's fine. You just don't want like toxins in it. You don't want any lead. You don't want any mercury. Other than that, water's water. Okay, I should be more careful, but, we drink water to hydrate ourselves. We tend to get our minerals from our foods. Yeah, why does everyone, Gray's got a great question there. What's your favorite color? Gray's saying green and gray. Everybody drop in the chat the emoji heart of your favorite color. Wow, we're getting some beautiful ones over here. We got like an interesting rainbow pattern going on over here. But we did have the question from, I want to make sure I got the name right. Who was that? Mike. Mike wanted me to blow through a straw into some alkaline water, which is what we're going to do now. Here we go. Hey, I see some of the emojis coming through. We got Dag with a green heart. We got Wasabi Noodle with a pink heart. Okay, I'm going to exhale through a straw into this flask here, which is pH kind of like 9 right now. Watch what happens when I exhale through a straw into this. Isn't that beautiful? Isn't that absolutely beautiful? So yeah, all I'm demonstrating there is that carbon dioxide, which is in my exhaled breath, changes the pH to 6. We went from 9 to 6. That means the acidity, because pH goes on a scale of powers of 10, a pH of 6 is 1,000 times more acidic than a pH of 9. So just by exhaling into this, I change the acidity that much. So carbon dioxide, when it dissolves in when it dissolves in water, is an acid. Anyone noticing sort of the red finger that's growing down there? That's really cool, huh? We got like a really interesting pH thing going on here. Let me get a little time while we're looking at this beautiful color here. Man, that's cool. Let me look through the chat here, see what folks have been saying. Hello there, Jamal. Hello, Eric says purple. Dag says green. Wasabi Noodle pink. Eduardo, light blue. Mike is saying this is fish tank knowledge. Hey, Jamal, thanks for the subs. Their favorite color is red. John Doe's favorite color is blue. Gray, of course, likes gray and green. Dag Silgad gave me a little emoji there. I'm not real sure what that emoji is, but I like it. Cool there, Mike. Glad to hear that. They don't have a gray heart emoji. I saw that. Uh-oh. Wasabi Noodle has shown the gray heart. Thank you there, Eric. And Baldric likes some green and lilac. All right, let's get back to, while we are watching this interesting pattern develop over there on the left, let's get back to seeing if we can generate some rainbow. All right? I agree, Dag. It's always a little weird to see, man. It's always a... Eduardo, is that a way to make sparkling water? Not really. I mean, yes, the concentration of carbon dioxide in here is higher. However, it's not high enough to make it sparkling. So we talk about the way it works is if I put a gas above this, then that gas is going to dissolve into the water. So, I expose this water to carbon dioxide, and so some of the carbon dioxide dissolved in the water. Now, how much carbon dioxide dissolves in here depends on the pressure of the carbon dioxide you expose the water to. When we exhale, only like 4% of our exhaled breath is carbon dioxide. And in terms of the way we measure gas pressure, that's only 0.04 atmospheres. So we measure gas pressure with units called atmospheres. 1 atmosphere is just the pressure of the gas pressure of the atmosphere. So when I expose this to 0.04 atmospheres, I can get it down to like pH 6 or maybe 5, but that's not nearly enough to get, the 0.04 atmospheres is not nearly enough to make the water sparkling. If I want to make the water sparkling, let's show you how we do it. All right, we'll show you this. We need to expose the water to much greater than 0.04 atmospheres. So here's how you do that. You all know how this happens. What I'm going to do is I'm going to take a soda stream machine. All right, we'll take our soda stream machine. This pumps out, if I push the button at the top, which you can't quite see, but you can hear it, right? You hear it hit my hand. This will pump out like 5 atmospheres of carbon dioxide pressure. So let's show you what happens to water that is, yeah, we can use some of this. This will work. Oh, this will be fun. You guys will like this. So what I'm going to do is I'm going to take my soda stream bottle right here. I need to get this water out, so forgive me a second. I'm going to pour this water out. Pour that out. And I'm going to pour into my soda stream bottle. I'm going to pour into it again, some of my very alkaline water, my body armor, which we saw was like pH almost like 9. So let's fill my soda stream bottle with a little bit of body armor water. And then I'm going to add some universal indicator to it. There we go. A little bit more. Right up to the fill line. Okay. Got that done. Let me put it right here. Let me put it right here so we can see it. All right. So let's add our universal indicator. See what our pH is. Looks like the glitch in the matrix, huh? Let me just see a couple of comments here. I've dropped the comments here. Thank you there, Eric. Green and light. Let's see. Carbon dioxide. I don't have gray heart. Left one looks like a glitch in the matrix. I agree. Experimental chemistry. Let me go ahead and add a squirt of universal indicator here. Well, that's odd. Why did that show up yellow? That's not what I was expecting. I think there's probably some residual carbon dioxide dissolved in the water that I had here. I'm just going to give it a drop of sodium hydroxide. We're going to go ahead and just make it. By the way, I don't use these bottles for drinking. I use them for experimentation. Okay, so we know that this water is violet. Remember, when I took the violet water, here, I'll just show you. Take the violet water and I exhale into it, I can get it to yellow. Now we're going to show you what happens if we pump a higher concentration of carbon dioxide into it. Here we go, baby. Hook that up. We see it's violet. Give it a pump. And it's orange. Give it another pump. And it goes red. So by exposing the water in here to higher and higher pressures of carbon dioxide, you can see that the pH is getting lower and lower and lower. And that's indeed because the higher pressure of carbon dioxide I can get in here, then the more carbon dioxide I can get dissolved in the water. And what's interesting is you can even see sort of the pH gradient, right? You can tell that in the foam where the carbon dioxide is escaping, the pH is lower than what's dissolved in the water, which is kind of interesting. All right, I'm going to open this up and hopefully the foam doesn't spray out everywhere. Oh, we're good. We're good. So I can just stick this right there. You can give it a view of that. You can see the red. And up at the top, you can see the sort of the yellow where the carbon dioxide is escaping and the pH is lower. And you can see the bubbles I indeed made sparkling water. Fun fact, the max amount of characters on a YouTube short comments is 2,000 characters, but on live it's around 500. Interesting. Nothing fun about that fact. Calcium hydroxide is also a base. All right. Yes, indeed. Yes, indeed. Look at that color that we got going on there. That's kind of cool. Now, what I like is on this flask over here, I do not know if I have more acid or base. I mean, it's going to take a long time for that whole thing to equilibrate. Is there more acid or is there more base? Well, we can figure it out by mixing everything up, and it'll work like this. It'll work like this. I'm just going to turn the stir bar on. Everything's going to get mixed up. If there's perfectly balanced acid and base, it'll go pH 7 neutral. It'll look green. If there's more acid, it'll look yellow, orange, or red. The more acidic it is, the more it'll be towards this end. And if there's more base, it'll look aqua, blue, or violet. And the more violet it gets, the more basic or alkaline it is. So let's give it a swirl. Sir, may I ask how they're getting 5 atmospheres pump? Is it a canister or some sort of mechanical pump? There's a canister that you stick in there. Here, I'll take it out so you can see it. Here, let's turn this on while I'm talking. I'll just take the, I think I can get it out. Wait a minute, how do I do this? There's just a canister that you buy. Take the back off so you can see it. And look at that. It's like a pH of 9. So here's the canister. Right there's the canister. Let me back up the, there you go. It's just a canister that you stick in the back. All right, Soda Stream. I'm not selling Soda Streams. I guess I could link it in there. I could link it in the, you know, in the chat so people can go back. Not the chat, but I guess I can tag the product if people want to, you know, purchase one of these, play around with them. They're kind of fun. Very easy experiment to do once you have it, once you have the equipment. And now I can't figure out how to get this back in. There we go. I don't know what I'm doing. There we go. Got it back. All right. I got some other experiments I want to do. I got one more I want to do for you before we call it quits. You'll like this one. I'll love this one. Okay, here we go. Let's do this one, baby. While this one is going, I want us to, of course, let's set this up so we can see the patterns developing over here. So I'm going to acidify it first. Let's get this nice and acid. 3 drops should do it. Okay, now I'm going to turn this off. Turn that off. We don't need to hear that spinning. And I'm going to add a single drop of sodium hydroxide base, and we can watch the static development of the reaction between the hydrochloric acid and the sodium hydroxide base. How do icebergs get a lot of carbon dioxide? Eduardo, I'm not 100% sure what you're asking, but it is the case that water does, like with the CO2 in our atmosphere, it does dissolve into the water that goes into the oceans. And that water ends up making the iceberg. So CO2 gets trapped into icebergs and the water just from the CO2 that's in the air. And what's cool is, what's really cool is in the ice down in Antarctica that, new layer gets deposited, new layer of ice gets deposited every year. And because of this, you can drill down into the ice down in Antarctica and you can sample the different layers and figure out what's happened to the concentration of various gases over time. They can go back it's close to 1 million years. It's remarkable. It's absolutely remarkable. Anyway, let's do this particular experiment here. I've got some water. And to this water, what we're going to do is we're going to add some acetone. So let me put my funnel up here. All right. You're going to love this experiment. I love this experiment. This is just kind of fun. Let me get my acetone out. Pop the lid. There we go. There we go. All right. Pour it in. Hopefully I won't spill too much. All right. So I'm adding acetone to some water that's already in my bottle. Fill that all the way up. I'd say right about there is good. That's probably good. Okay, now that I've got that part done, I'm going to add a drop of purple food coloring. You're welcome, Eduardo. Let's, we're going to watch. Oh, we're just going to check it out, man. So let's add a drop of purple food coloring to this. You can probably see that there's like 2 different layers. So you might be able to see that the acetone layer is kind of floating on. You can see kind of an interface here. There's kind of the water layer and the acetone layer. Just so we can see this, I'm going to add a drop of purple food coloring to this. Oh, that's gorgeous. Look at that. Just look at that. Oh my God, that's beautiful. So what's interesting is the food coloring sinks down to the level where it is more dense than the surrounding fluid. So it drops this far and it just kind of stops right there because the density of the food coloring is higher than this fluid above it, but it's lower than this fluid below it. Let's add one more drop. That was very beautiful. I agree, Gray. Let's add another drop, see what happens. All right, now we're going to mix it all up. Look at those strands of color there. Very cool. Let's mix this all up, and we're going to see if the water and the acetone mix. If they don't mix, we should see 2 layers, right? If they do, we should just see 1. So I'm going to mix all that up and see what happens there. So long, Gray. Thanks for joining in. Thanks for the feedback. Looks to me like it, the alcohol, excuse me, the acetone and the water completely mixed with one another. Okay, fair enough. Now what we're going to do, though, is we're going to add some salt. So I'm going to pour salt into the bottle. And salt does something that we chemists call salting out. So what it will do is it will salt out the acetone from the water. All right, I gotta get a funnel that's gonna work. I gotta get a bigger one. This one should work. It's not gonna be perfect, but it's the best I got. I don't know where my other one went. Curses. I guess I could use the smaller one. Let's use the smaller one. This is gonna take a little bit longer. All right, man. Here we go. In goes the salt. Now, the water and the acetone, they actually attract one another. That's why they are able to dissolve together. So, you know, just like people. If people are attracted, they mix, right? Kind of the way it works. You can think of it that way. But here's the deal. You know, you can think about the acetone and the water kind of like, you know, a couple, two people that love each other a lot. And then this other person comes along. It's the salt. And the water says, you know, I'm kind of more attracted to that salt than I am the alcohol. This happens with people too, right? And so what happens is the salt and the water, those two are the ones that mix, that attract and stay together. And the acetone, well, kind of gets pushed out. That happens sometimes, right? Let's see how this looks with molecules. So remember, what I have in this flask is some water, some acetone, some food dye, and some salt. And I'm hoping we might see something here. Come on, baby. Come on, baby. It's working. Look at that. Ha, I love it. Ah, that's beautiful. Absolutely. They get salty. I love it. Isn't that beautiful? Oh, cool, Mighty Mouse. That's cool, Mighty Mouse. Acetone is just a molecule. It's like an organic molecule. Isn't that beautiful? So what happens here? There's a lot going on. Remember, the water and the salt combine and they're very attracted to each other. They push the acetone out. But we can see that the purple dye is actually made of two different colors. One that's kind of bluish and one that's sort of this magenta color. And the magenta color likes the acetone, whereas the bluer color, well, that likes the salt water. So what I do now, I'm going to go ahead and flip the camera around and talk to you guys. If that's not something you want to see, then it's time to get on out of here. You're going to see an old man in their basement. I'm just going to say hi to folks for a bit. Hello, everybody. Hope you had a good day today with our live. If you got any questions, you just want to talk a little bit, I'm here for you. Hope everyone enjoyed today's experiments. Thanks, Eduardo. Thank you, Eduardo. Thanks for joining in. Where'd I get the shirt? I got it in Sedona, Arizona. I love the place. Thanks, Shaz Kaz. Hello there, I'm Wee Todd. Thanks for hanging out, folks. Hope you had a good time. I'll probably head on over to TikTok for a little while, do a little streaming over there. If you follow on TikTok, I'm probably just going to do the same stuff this afternoon. Hope you enjoyed the live today. And if I don't see you on TikTok, hey, thanks there, Chaz. I appreciate that. If I don't see you on TikTok, maybe I'll see you here next week, all right? So long, everybody. Have a good day.